Guys, so today we're going to be starting the fourth and final unit. This is a super short unit. There's only 2 lessons. Today's lesson, we're going to start with some definitions. We're going to go over how to kind of collect data, what the best methods for data collection are in different scenarios, and then how to evaluate the data that you've collected. So this lesson is all about data collection, and let's start with some of these definitions. So a respondent is a person who answers the questions or responds to a survey or a census. A survey is a series of questions used to gain understanding about people's opinions on a topic. A census collects data about the whole population, so like how old they are, where they live, that sort of thing. A population is the total group of people involved. So a population doesn't just refer to like the population of a country or the population of a city. It could be the population of a school or the population of athletes on the volleyball team. Any kind of closed group where you include every member of that group is a population. A sample is when you just have part of the population. So if you had a sample of the school, that would mean that you had asked some people in the school to respond to a survey, but not everyone in the school. A representative sample is a sample where it essentially matches the whole population. So it has the same gender ratio as the entire population and the same age ratios as the entire population, that sort of thing. So for example, if again the school was our population, a representative sample would have the same ratio of boys to girls as the entire school does. It would have the same ratio of students to teachers as the entire school does, that sort of thing. And then a random sample is when the people that you're asking questions to in the population are chosen at random. It's just like whoever you bump into first, that's who you ask. Okay, bias is really important to identify when you're doing a survey or something like this. Bias will make your results invalid. So you really want to make sure that you avoid anything that could be construed as bias. A biased sample means the people in the sample are not a good representation of the whole population. So for example, if you were doing a survey on our school population and the sample that you chose was only grade 9 boys, that is not a very representative sample. It would be very biased. It wouldn't take into account anything that girls might have as different opinions or anything some of the older students or the teachers might have for opinions, that sort of thing. A biased question is a question that is worded in a way that will influence how people answer it. So things like use of language or like the adjectives that you use can result in a biased question. So for example, would you rather have a boring office job or an exciting trade job? If you just took out the adjectives boring and exciting, this would be a perfectly valid question. But by adding in those adjectives, you've made it biased because you're trying to influence people to choose the exciting trade job over the boring office job. So yeah, that's one way that you can create bias. You can also create bias by making people uncomfortable with your question. So if it's like an invasion of privacy, then people might not answer honestly. So things like asking about like how much money do you make, or how much do you weigh, or have you ever had an STI? Like anything that might have like some stigma attached to it, and people might not want to tell a perfect stranger, would be a biased question because of privacy concerns. There's also like cultural insensitivities that you have to take into account. So if you're going around and asking people like, you know, what did you have for lunch today? Which might seem like a perfectly innocuous question. And your like answers are like, I had beef or chicken or pork. You are, or, you know, a salad, then you might not be taking into account someone who is like fasting because they're Muslim and it's, you know, the middle of like Ramadan or something. So you want to like keep those cultural sensitivities in mind as well. So there's a lot of different things that can cause a biased question. Then you also have to identify, is the data you're collecting part of a survey or part of an experiment? So if you're collecting data on something that is like people's opinions, then that's going to be a survey that you're doing. So if you're saying like, what's your favorite color, what's your favorite sport, or that sort of thing, all opinion-based, it's a survey. If you're gathering facts, then it makes more sense to run an experiment. So if you're trying to see like, how often does buttered toast land butter side down, you're not just going to go around and ask people what they think. You're going to actually take a piece of buttered toast and drop it a bunch of times and run that experiment to see what happens. Okay, when creating questions for a survey, you want to make sure that your questions are appropriate. So the first thing is they have to be easy to understand and easy to answer. So having like a lot of like short answer questions in your survey doesn't always make sense because people don't like answering them. They would prefer to answer something that is multiple choice. You also want something that's effective at gathering the data that you want, and by putting in possible options, it makes that more easy. You don't have people answering in ways that you didn't expect and didn't account for. You also want to make sure that your questions aren't too vague, again, so that you actually get the kind of data that you're looking for. You want to order the questions in a way that makes most sense to the respondents. So if you're asking like similar types of questions, group them together and then change topic if you're going to ask something else. Again, make sure that they're not biased. So that includes, you know, not using adjectives, for instance. Make sure that they're sensitive so people don't feel like their privacy is being invaded or that they're being judged by how they answer. Make sure that they're culturally sensitive. So again, we talked about, you know, making sure that they apply to people of all cultures and kind of mean the same thing to everyone. Make sure that it's respectful. You know, it shouldn't be something that's going to offend someone if you go up and ask them. And make sure that you tell the respondents why you're collecting the data. When deciding whether it would be better to do a sample or a population, there are a couple different things that you need to take into account. First of all, a population is always going to be more accurate than a sample. So if the most important thing is accuracy and you have unlimited time and unlimited resources, go with a population over a sample. However, if the population is large and you don't have unlimited time and or you don't have unlimited money, then it just might not be feasible to survey an entire population. Populations are really expensive and really time consuming to ask everyone if they're large. And so that is one reason, or two reasons, I guess, why you would do a sample instead. If you have a limited amount of time and a limited amount of money, do a sample instead. If that's the case, just make sure it's a representative sample, that it's not biased, so that it can be as accurate as possible. It is important to note that random samples are not as good as representative ones because sometimes just by random chance, your random sample ends up biased. So again, if we go back to that school population, and it just so happens that everyone you bump into on that first day, you know, is a grade 12 student, then it ends up being biased towards, you know, what applies to people that are graduating more so than what applies to younger students. Okay, so after you do finally collect all your data, you then have to analyze it in order to actually figure out the answer to the questions that you are hoping to answer from that survey or, you know, whatever experiment. So the end result of the analysis will get you your conclusion, what you discovered from going through the data. When you share your conclusions, other people have to be able to judge how reasonable or accurate your conclusions are. So when you're giving people what your conclusions are, you also have to tell them how many people you collected the data from, how you decided, you know, what sample to use, how you actually collected the data, what questions you used, all of that sort of thing. Your conclusions may be inaccurate if you surveyed too few of people. You need a fairly large sample size in order to be accurate. That is why when there are like, you know, scientific studies and stuff, and they say like, oh yeah, and all of this was tested on like 6 participants, right away you can like pretty much throw out any of that data. It is not a large enough sample size. If the sample was biased, so for example, if you only did your scientific study on men, which up until like very recently has been incredibly common in like medicine for like scientists and doctors to only study male patients. If the questions were biased, we've already talked about what makes a biased question. If the questions were confusing, so people were just kind of like guessing. If the conclusions don't match the results, so if people like go through your data and say, I don't think the data says what you think it says, or if you made some incorrect assumptions. And then you also want to display your data in a way that's easy for people to read and interpret it. This could be in a table, but if possible, it should also be represented in a graph. So either a line graph, bar graph, even a pie chart, or like a circle graph. And it's really important that when you're making these graphs, especially if it's a line graph or bar graph, that you pick appropriate axes values on which to show your data. And this is also something to look at when you're analyzing someone else's data to see if they're trying to kind of trick you. People can manipulate how the data looks by changing, especially the y-axis. So that's something to pay really close attention to. Obviously, with bar graphs and line graphs, you want to make sure that both the x and the y values are going up. First of all, that they're going up is one thing. Sometimes it has been shown, even with like the whole like coronavirus, COVID-19 thing, people try and manipulate how the trend of the data looks. This was happening in, I think, Florida, somewhere in the States, where along the x-axis, what should have been like time going forward, they had like the dates all over the place. It was like, here's like, you know, March 27th, and here's May 13th, and then here's April 8th, and like it wasn't in order, to try and make it look like they were flattening their curve. So pay close attention to the axes. They should be going up or going like forward if it's time. And they also should be going up by a constant amount if it's like a linear graph. Which is a lot easier to interpret than like an exponential graph. That is also a possibility, but yeah. And then you want to make sure that what the graph is telling you it represents actually matches what the graph is showing. So I'll go over an example of that in a minute. And then with a circle graph, you need to find out how much of the circle each section gets. Again, sometimes people just like randomly put in numbers and they don't even like add up and stuff like that. So yeah, what you do is you divide the number in that section by the total number of the survey and then multiply by 360 to get to the angle of that pie piece. So we're going to go through an example of this as well. Okay, so firstly, just an example of kind of how to interpret a graph and what a good graph looks like. So this is an example of a graph that was posted by Reuters, and it shows the number of murders committed using firearms over time. And it's specifically wanting to draw your attention to this area right here, the Florida Stand Your Ground law, which essentially says if someone comes onto your property, you can shoot them if you need to. And in this article, it was talking about how after the Stand Your Ground law was enacted, the gun violence decreased. And it's this right here. So take a look at this, see if you can figure out what is wrong with that conclusion. And pause here if you don't want me to give you the answer right away. But the issue is our y-axis. As you might notice over here, our y-axis is upside down. It should start at 0 down here at the bottom and go up to 1,000, and they've reversed it to flip it upside down. And the only reason that they could possibly have for doing that is to make this look like the Florida Stand Your Ground law decreased gun violence. Because really, you should flip this upwards, and that's what this graph would actually look like. In reality, the murders committed using firearms dramatically increased following the Stand Your Ground law being enacted. And they are misrepresenting that by flipping this y-axis upside down. By the way, this was the other graph that I was talking about with the COVID-19. It's actually for Georgia, not for Florida. But as you can see at a quick glance, it looks like the number of cases are dropping down. But if you actually pay attention to the x-axis down here, you'll see that the dates are all out of order. We have April 28th, then April 27th, April 29th, May 1st, back to April again, May 4th, May 6th, May 5th, May 2nd, May 7th, back to April again. So by manipulating the x-axis, they can try and influence you to believe something that's not true. Okay, and then lastly, in terms of that circle graph, I'm just going to go over again how you figure out what angle each pie piece should get. You're never going to have to actually draw a pie chart on a test or quiz or on the PAT, but you may need to say how big of a pie piece it gets or what angle it'll have. So in the example, I said 400 people were surveyed about what their favorite sport was. 120 answered that hockey was their favorite. And so what piece of the pie should that get? We're going to start by doing 400 and dividing 120 by it. So 120 divided by 400. I don't know why I said it backwards first time. 120 divided by 400 is 0.3. And then our second step is to just do 0.3 times 360, which is like a full circle. So 0.3 times 360 is 108. So that would be your answer. It would have 108 degrees of pie piece. Okay, that's it for today.